this is all set of ordered pairs, this can be a function. Now what is the restriction here? Now if you take this set of ordered pairs and I put another point here, now I have, for same x value, how many y values I have? Same x value, let's consider this one. How many y values I have? This is 3 and this is 4. So I have 1 and 3 and 1 and 4. So now I'm going to say, because for same x value I have two different y values, I'm going to say that this is a restriction. This is not a function. So whenever we consider set of ordered pairs, if it's a function or if it's a relation, all we have to check is, for the same x value, is there two different y values? Can this happen in a function? No. So if this is the case, what are we going to say for this? Not a function. This is not a function. So you guys basically got what to check on a function already from the diagram. But now apply these to, so given this, for an example, if you're given set of ordered pairs, question here is f, this set of ordered pair is called f, is a function or not. So what do you need to do? Is this a function or not? Given a set of ordered pairs, this question is asked. And I just explained to you what you need to check for a function in set of ordered pairs. What are we doing here? For the same x values, do we have a same x value here? No. In this. So we don't have this. So this is already qualified, right? Because same x value, it cannot have two different y values. Set of ordered pairs where for two ordered pairs with the same x values cannot have two different y values. Cannot have two different y values. Okay? So we don't have that in here. So therefore this is, what's the answer to this? Yes, right? Okay, so let me write the definition now. So let's write the definition. You can just write it in your own words. You understood exactly what it is now, right? So what should I write? It is so this is the definition in our own words. The book has another way of saying this, but it's saying the same thing. Okay? It is we can call it a set of ordered pairs, right? Even when you have a graph, this is also set of ordered pairs. Whatever graph is a set of ordered pairs, right? Later on I'm going to talk about functions in different ways. It is a set of ordered pairs. Ordered pairs. So what do you need to say now? Such that, right? Matthew? What do you want to say?
They don't share an x values.
They won't share x values?
For every x is one y.
For every, yes, you can say for every, let me write like this, yeah, you can say it's for the same x value, right? There's only one y value. You can say like this, for the x value, for the same x value, if the x values are the same, you can have only one y value. Okay, so all I'm going to say was such that two same, I'm going to say like this, two same, can I continue here please? Two same x coordinates, right, cannot have what?
Same y value.
Different, right? two different, or in case this is two, different what? Y coordinates. That's all we need to check. For the same, if for two same x coordinates, so you have to, two same x coordinates. If you say this way, you need to use the word cannot. Okay? Cannot have two different y coordinates. Because I'm writing like this is how I explain it here. I said this is not a function because it has a two different y coordinates for the same x coordinate, right? So it's easy for you to know exactly what's the function, right? Okay, guys. Now, so everybody know what's the relation, what's the function. Now there are some properties of functions. The book has listed these. But I will discuss that in a little differently. Okay, so we know functions. Now the third thing about functions. So first one was relation, second one is function. This is the definition for function number 2. The definition for function, we explained. Number 1 is what's the relation. Number 3, I want you to know types of functions. I'm going to say this as functions. Functions can be given. Given as. So functions can be given as. For now, I just want you to know functions like this. Later on, I'm going to consider what is domain, what is range, and given two sets. Later on, I'm going to do all that. For now, let's look at this only, okay? Now, I'm just going to write the page here. The ways to represent function, page 186. The book has ways to, this is page 186. I'm just going to write this little differently, it's the same thing. Functions can be given as number 1. What is the book has for number 1? We can just write the definition, right? Book has verbally. So functions can be given as, you can say just use the definition. Use the definition. Use words, right? You can always express the function with the definition, right? Number 2, set up. The definition, in this definition, what we use, we are going to use as set up what? Ordered pairs. Number 3. Graph. As a graph. Anything else?
Algebraically.
Huh?
It says algebraically.
Algebraically. So if you are using a function algebraically, how will you use the function algebraically? Huh? As an equation. As an equation. So as a formula. Right? You guys know we talked about functions. I said f of x. Remember last class meeting I said f of x equal to, we did this ax squared plus bx plus c. This is, I call this a function, or the parabolas are function when we discuss about parabolas, right? I said this is a function, remember? We also talked about f of x is equal to ax. Last class meeting we said x mx plus b. We did this, right? So these are You guys already have seen this type of formulas, right? There is an algebraic way a function can be described. Not all formulas are functions, not all equations are functions, right? Only some. Any other way. Functions can be given as so graphically is by graph, numerically ordered pairs, right? And verbally by using the definition, you explain the definition. And number 5, some have function machines. You can also give a function as function machine, as a function machine. For an example, it's like this. Your book doesn't have this. So this is a machine inside. Inside the machine something is happening, right? And the same thing is continuously happening, right? Whenever we are using it, right? So let's consider this is something like x squared. There's something x squared is happening, right? So we are going to, for a machine, in order for the machine to work, what do you need to put? What do you need to do? We have to put something, right? So let's say we are putting some dollar bills here. We are doing $1 bill, and then $2 bill, and then $3 bills, $4 bills, like this. Okay? And then, so x is, so if you consider x is one of these, either $1 bill, $2 bill, $3 bill. X is the numbers that we are putting inside this machine. So then the machine is giving something. So what does the machine do? You take x as 1, it squares. Machine is somehow multiplying it, making it bigger, more, right? So now what do we get? 1. And then if you put $2, what happened? 4. If you put $3, what happened? 9. And 16 and
25.
Yeah, 16, 25. So you know this machine is meant to work like this. Okay? Now, whatever you put in the machine is called what? This is your input. What is this called? Output. Now, in your definition, if you look into your book definition, it does say something about, in the definition, it says about domain range. So far, I did not talk about domain range, right? But now you guys see now, this is definitely a function, because when we graph this, the graph is going like this, it's a parabola. So it is a function, this operation which is happening is a function. Not all operations are functions, we know that. But this operation is a function. So we know whatever we put all the stuff we put inside the machine is called input. Always input values are the it is called the domain, which is all the possible x values. Domain is, in other words, we say this is x values, right? We are considering, right now we are only considering functions of 2 variables. So the domain is x, y is the output value, right? So what do we have to say here? All possible. So what is the domain? Now I'm writing the definition for domain as well, okay? Because we can describe what is domain. This is a good example for you to see. Input is your domain. All possible values, right? So, so what is domain here? All possible x values. all possible x values. Domain comes from all possible x values for the function. Now, what is range? What do you call these values? Output values. The output values are called range. Output values are called range. Okay? So what is range in here? What is range?
The Y values?
Yeah, so in a function this is called the y value. We are only considering for this class functions of two variables, okay? So the range is all possible y coordinates. Okay? All possible y coordinates is the range. Now, so we know functions can be given like this, right? Number 3 is I'm going to write, no, this is number 4, right? Number 4, function notation. Notations. Function notations we are going to consider like this. F of x. F of x, this is how we say if it's in terms of x, the variable is in terms of x, we are going to say something like this, 2x squared plus 1. This is a function, f of x. The f is the function name. This function name is with respect to what? X. You guys following this? So this is here, f of x is here, what value? Y value. But instead of saying y, we say f of x. Okay? F of x is always the y value. This is the function name. This f of x is the name of the function. Now if you consider this one, I'm going to say I can say this, d of t is equal to, if I give this, 3, I had to put a variable here, minus 1. What should I put here? What variable? Can I put x here?
T.
Yeah.
T, very good, because this function is with respect to t. So this is d of t. D is the name of the function. In other words, so you guys have seen graphs not only with x, y, you guys have seen graphs like this also, right? This is the d stand for distance, t stand for time. Have you seen graph like this, d and t? And if you have something like this, this is the function. Okay? So this is the function with respect to t. So this is the function notation for this graph. You can't say for this graph function notation is f of x.
So is D and T still your y in that?
Yeah, d of t is your y value. This is just a name. Because in words, real life, the word problem are not always x and y. Word problems have different variables, right? So different variables. So x can be addressed as a different variable, y can be addressed as another different variable related to x. Familiar with that? Yeah. Are you familiar with it? Okay. So another example you can say is with respect to time, you can say, let's say the grades, right? The exam grades, right? So the exam grades, so I'm going to say the grade G. Grade is, I'm going to say the grade that you take is depend on the time that you spend. Right? Isn't that a true statement? 99% I think it is true statement. More time you spend, yes, of course you can get a better grade. Okay? So, so this one I can say like 40 squared, something like this. Okay? So these are the function notation. So you have to make sure that if the x is given f of x, this is what? This side, the formula is supposed to be based on what? X value. T. Okay? Okay, so guys. So we know what's function notation. Number 5. Given any relation consider if the relation is a function or not. Not a function. Okay. Now before I do that, before I do this, I have to do something. So let's do this. I have to give you a rule. We know that all set of ordered pairs are not functions, all graphs are not functions. If you say graphs are functions, is it a true statement?
No.
No. Okay, you have to be careful. If someone says graphs are functions, true or false? No. Only sometimes. Right? All formulas are functions, true or false? False, right? Formulas are function false because it's only sometimes. So because it's only sometimes, we have to check, right? So this is a check to see whether a given graph, how to check a given graph a function or not. Okay? So this is called vertical line test. Vertical line test. We use vertical line test, to consider a given relation. So everything is a relation. Given anything, we can call a relation. Any formula, relation. Okay? Any set of ordered pair, relation. Any graph, relation. Okay? Relation is a what? Function or not a function. So this is what we are going to do with this vertical. Have you guys heard vertical line test?
Yes.
How many of you heard? Okay, vertical line test. You remember, Elizabeth?
A little bit. I know it's like if it goes straight, they can't cross the same, the x value twice. Wait, is that right?
The same Y value.
Same y value,
Same
that's
Y
what it
values.
is. Yeah, so like if you use the line, so it can't go through the same.
Yeah,
Twice.
very good. I think you got it. Yeah. So let's go through this. We said a graph like this, a parabola, is a function. We said graph like this is a function. So the vertical line test is this. You draw vertical lines. Can you draw a single vertical line for this graph that cross the graph more than once? Any vertical line that cross this graph, the most time it is crossing how much? How many times? One. only once. So this is a function, is a function. So all you have to do is draw vertical lines and see whether the graph is crossing the vertical line. You have to make sure that any vertical line that we can possibly draw, the graph can cross the vertical line only once. If it crosses twice in one little tiny area, then the graph is not a function. Clear, right? Okay, so let's do this. So now how about graph going like this, but like this now, and then going like this. This is also graph. You can have all sort of graphs, right? But in this graph, let's check. Are they any vertical line? Oh my gosh, I'm not drawing straight lines. Not good that way. Do you guys see any vertical line that this is the test now, we are doing the test. Do you see any vertical line that cross more than once? Can we possibly draw one?
Yeah.
So far you haven't seen it, right? But the question is, can you possibly draw at least one?
Yeah.
It only takes one,
Yes.
okay? So can we draw one? If you go through a vertical line here, it's definitely crossing more than once. There's a tiny, like a little vertical line. So this means for the same x value, see this is the same x value in this vertical space, right? How many different y values? There are lots of different y values. We only have to take 2. Are you following that? So this is called, so what's the answer to this? Not a function. Not a function. So you only have to say, do the vertical line test, okay? You only have to do the vertical line test. Okay, guys. So now given, so I did already the first one. Example number 1, you will say f of 1, a function or not. So these are test question now. Now class, this test is very straightforward. It's all from your notes. I can't give you a makeup exam. I'm sorry, it's called practice exam, okay? I want you to study, make sure that you know how to do every single problem that I write on the board. That is your makeup, the practice exam. So you already have done your practice exam. When it comes to the exam time, what do you need to do? You need to redo it. You need to redo it like 3-4 times. You can't just study very similar to makeup. Maybe later on I'll give you another practice exam. I want to see how you're doing for this test. I'm not going to make the test difficult. It's just basically the test questions that I write on the board. Okay? Okay, and you guys can. So test question here. So what do? Similar. So I will have some points like this. Function or not?
Not function.
So we know exactly this is right. So this test question, very easy. See, you already know what to do. So you are very thorough with the concept, not a function. That's all you have to say. You don't have to give your reason. You don't have to explain. You know why it is not a function. So you can also have something like this now. Another example. Given a graph like this, a function or not. Is this graph a function or not? No. You know you can do a vertical line, right? There's one vertical line. And if I ask you to explain, you can also explain. Sometimes I can say explain. So you say no, and if I ask you to explain, you know how to explain this. So explain, so the answer is no, explain. Explain why. How do you explain? Yeah, there is a vertical line that crosses the graph more than once. So what's the answer?
Not a function.
Not a function, not a function, not a function. Explain. Find, we can find, right? Can find vertical lines that cross the graph, right? That intersect the graph or cross the graph. Cross the graph more than once. Cross the graph more than once. So I'm just going to graph more than once. Everybody good? Okay. All right. Now, okay, so let me go into, I think I'm spending too much time here. I'm going to do, okay. We are good. Okay, so the next thing we are going to know is, so we did number 5, number 6, how to evaluate a given function. How to evaluate function values. Okay, so this is the example we get. F of x, we are given that f of x equal to x squared plus 2x plus 1. Find f of negative 2. Or find f of negative 2/3. What do you need to do? You just have to plug it in. Very easy. Okay? So f of x, this is the function. So this is the general formula. But we want to know a specific, for specific input, what is the output? That's what it means. Okay? So what is the input, the first part?
Negative.
Negative 2. If the input is negative 2, what's going to be my output? You had to substitute it really correctly here. If it's a negative number, write parentheses. So what do I get here? This is 4 minus 4
Plus 1.
plus 1, and it is 1. So f of negative 2 is equal 1. What this means is on the graph there is a point, negative 2 and 1. This is part of one ordered pairs of the function that we have here. So you guys understand the story behind what this means, okay? Because you know what is x means now. We have seen the diagrams, we can relate to what we see here, okay? Okay, so the same, now this example, part B, so this is A, this is B, part B says what? F of negative 2/3. Now guys, I'm sorry to say this, on the test, some of you guys have lots of problems with fractions. You didn't know how to add subtract fractions. Okay? So in this one, what do you have to do? X squared plus 2x plus 1, negative 2/3. So you need to know how to work with fractions. This, I can't teach this, but I'm just going to do the problem here. Negative 2/3 plus 1. So now we cannot multiply everything by 3, right? We can't do that. This is just, we need to evaluate this. It's not solving an equation here. Okay? So some of you guys did that, multiply by 3, but you didn't multiply. You see what I mean? So this is also negative is positive. 4 over what? 9. 3 squared as well. 9. 4 squared over 3 squared is 4. 9. Negative become positive. Right? Plus 2 times negative 2 is, so this is negative 4 over 3 plus 1. So something like this you should know how to simplify. What's the least common denominator here?
9.
You should know least common denominator is 9. So this we don't have to do anything. This we need to multiply by 3. Multiply by 3. This we need to multiply by 9. Right? Multiply by 9. Multiply by 9. So now everything we need to write out of 9. 4 minus 12 plus 9. So what do we get? 1, 9. Okay? Everybody good? So everybody know how to add, subtract, multiply, divide fractions anytime. This is not solving equation. You can get rid of the fractions by multiplying by the least common. You can't do that. You just have to evaluate this side. Okay? So what is the answer to this? F of negative 2/3 is equal to what? 1, 9. This means when the x value, you're going to see later on, you're going to find the possible domain and possible range problems. Not all x values are function, part of the function value, domain value. Okay? So sometimes it's all real numbers, sometimes only 0 to infinity, positive real number. All fractions or decimals sometimes. Okay, so this fraction and this fraction was the y value. This is an ordered pair. That's what it means, right? That's the input and the output value. So this, I am definitely going to have a problem test question. So you guys, when you see test question, what do you need to do?
Study.
Highlight it first so you know First you copy the problem, highlight and count how many test questions you have altogether. Okay? So test question, so I'm saying this, if the test question is already done for you. Okay? Okay. So there's also problems like this I need to do. Evaluate number 2, or example number 1, that is example number 2. So you will have f of x is equal to x squared, g of x is equal to 3x minus 1, and r of x is equal to x to the power 3. These are 3 different functions. Okay? 3 different functions. And later on we are going to learn how to add, subtract fractions and do some algebra with the functions. But for this class, if you are given like this is also test question. I can ask to evaluate, I can say find or evaluate, this is part A, evaluate f of negative 3 minus g of 1/4. So now what do you need to do? You just have to evaluate what this whole thing is, right? So if you have to evaluate what this whole thing is, you just have to substitute, that's all, right? So substitute, so you go ahead, so you first have to work with f of x for this one, right? So what is f of x? X squared. So f of x is x squared. So this means x squared minus, what is g of x? 3x minus 1. Now this is g of x, we just have to make a note here, g of x, this is minus g of x, okay? So you need to put parentheses. Now this is x squared, f of negative 3, you see we have to be careful. F of negative 3, this is negative 3, for x negative 3, and x squared means with parentheses square. F of negative 3 minus g of 1/4, this not problem is saying g of negative 3. This is g of 1/4. Later on you guys will see f minus g of negative 3. Then you put f for 3 and g for 3, same. But this one is definitely different variable values here, right? You can see that, right? For this, x value is 1/4. Later on you're going to see this also, okay? Okay? Alright, so now, so what do you have here? 3 1/4 minus 1 with the parentheses. What is this? 9 minus 3/4 minus 1 with the parentheses. So simplify this now. 9 minus, this is 3 minus 4, if you find the common denominator. So what do you get from this parenthesis? Do the parentheses first. Minus 4 is negative 1/4. So what's the value? 4 is the common denominator. 36 plus 1/4. Okay? Agreed? 37/4. So what's the final answer here? For this expression, the value is 37/4. So if it's given something like this, you know how to substitute and work on. Okay? Now sometimes you will also see find. This is also another example. I might have it on the test question. F of, let's say you have, f of x over g of x. Or I'm going to say f over g negative 2. So what does this means? You take f value,
X
x square over 3x minus 1. Evaluate this at negative 2. Work with this. Right? And simplify this. Right? So, okay, so we are almost done with this part here. I still have to do few things here. Okay, so this is how to evaluate functions. So we did that. And
Professor, what happened to the -2?
oh, I missed something there. -6.
The one that you multiplied?
Do we have to vote again?
Substitute this -2.
Yeah.
Oh, this means evaluated at -2. Both these functions evaluated at -2.
Oh, I
Okay? See that? Okay. Alright? That's like the notation of writing. Okay? Okay. Okay, guys. So, we did how many things? 6 things. Later on, we are going to do more problems with how to evaluate. Now, before that, after I do the algebra functions, we are going to do more of evaluating problems, okay? More harder problems. Okay, that's number 6. Number 7. Number 7, we are going to do, this is the most important part. Number 7, we are going to see some type of basic functions, right? Some basic functions. Some basic functions. Okay, guys. Now, this is where intermediate algebra and college algebra, I would say, pre-calculus, calculus, all these classes, you have to know all this basic function. With this basic function, we do a lot of stuff. Okay, we do a lot of stuff. So this is like knowing your timetable, right? Because with the timetable, with the other grades, we do a lot of stuff, right? We never forget, right? So the same thing here. So basic functions. Number 1. We can also call this, is also in some books, they call it as library of functions. Okay, so you can write as library of functions, basic functions. Okay, so number 1 is f of x. So you guys know when I write f of x, g of x, that means just the name of the function, right? F of x is equal to mx plus b. If we, this is, you know how to graph this, we did the graphs yesterday. What kind of graph we get from mx plus b? What kind of graph we get?
line.
Straight line, right? We get a straight line. Now, straight line is always a function. Now I am only writing functions. So when I say some basic function, I'm not going to tell you guys to here, we are not telling that these are not function or check whether these are function, right? Number 2, this is the straight line. So straight line is always. Number 2, call f of x. I'm going to call this all f of x. Okay? F of x equal to x squared. This is the quadratic function. We'll graph this. Number 3, f of x is called x to the power 3 cubic function. Number 4, f of x is equal to square root of x, okay, square root function. Number 5, I don't know whether the book has this, but I'm going to also give you guys cube root function. no cube root function, square root, exactly how this goes. Okay? Number 6, f of x is equal to, we also did rationals, right? This is called what? Rational function. The x value is in the denominator. Rational functions. Number 6. Number 7. Have you guys seen this? What is this sign for? Absolute. So absolute value function. Okay? Now we are going to, all this for now, the number 8 is piecewise functions. So some functions are not piecewise, but you can also give, I'll do number 8, number 9. There are lots of other functions, log function, but basically for now we are just going to go through these 7. Okay? Later on we are going to do some other functions. We are going to do logarithmic graph, logarithmic functions, and some other functions. Okay. For now, let's work with this so you get an idea. Some of these graph how they work. Okay. So now at least 6 of these I'm going to go through today. Let's see. Any questions, guys, so far? So now on the test. So these are test questions. These are all test questions. So let's do number 1, f of x. So if I asked you to graph this 3x minus 1, you know how to graph this center. Right? You know to do this. I'm not even going to do this. We did like about 20 different types of graphs like this. There are 3 ways to graph this, right? So you can choose any way to graph now. You know 3 methods, right? You just graph this. If it's have like a 4 here, it's still the same, right? You know how. Okay. Number 2. This is the basic first one. F of x is equal to x squared. So now when you do this, I always want you to, at the beginning, I'm going to say text question, graph the functions. This is the question now. Graph the functions, given functions, using first way of graphing this. What did we describe? How to graph it? Using a yes, very good. Table of ordered pairs. So just to feel what are the domain values, what are the range values, right? We need to show our work. We need to create the table. Okay. So this one, we know how to create the table for this. So let's create the table for this. So all you can do two table, like this is called T table, right? So put an x value, this is f of x value. You can do your work, whatever the mental math work or scratch work on a scratch paper. We don't have to show all the arithmetic here, right? So what do you do here? X values, you're going to pick some x values. Here we are going to pick negative. So pick some negative x values, positive x values, right? So always pick some 2, 3, negative x, negative 3, negative 2, negative 1, 0, 1, 2, 3. So these are the values. And if it's negative, if you put x squared, function is x squared. So we are going to, this is 9, this is 4, this is 1, this is 0, 1, 4, 9. We can pick more, this is just sum, so that we can get the feel for it, right? So now we are going to graph this. Okay, negative 3 and 9. So negative 3 and 9 somewhere here. Negative 2 and 4. Negative 2 and 4. 1, 2, 3, 4. Negative 2 and 4. Negative 1 and 1. 0 and 0. Positive 1 and 1. Positive 2 and 4. Positive 3 and 9. So guys, you see this, right? So now all you have to do is what? All you have to do is connect the dot. So connect the dot. Now we are not going to connect any way we want. We are going to connect the x values when, this. So you have to know how to connect also here exactly. See that? Now by looking at this, the next question, so you draw this, you create this, and then also I'm going to ask find the domain. D is for domain and R is for range. When we say D and R, D is for domain and R is for range. So what is the domain here for this problem? So domain is all possible. What is the all possible x values you can take here? We remember I gave the definition for domain, all possible x values. So what's the all possible x values here?
Negative infinity to positive infinity?
Is it just these values?
No.
Then what's the all possible x values?
Negative infinity to
Negative infinity to
positive infinity.
positive infinity. Open. This is the domain, because we can pick any x value on this side, we can pick any x value on this side. Can we can we reach a y value? Whatever the x value we can pick, we can find a y value. So for any x value we can find, we use for input, we put any x value, we get a output, right? So the domain is all possible x values, so the domain is this. So this is what you need to do. I mean, the problem is already done. You just have to, I just want you to understand how it works, because most of the problem is not going to give you just the ones that you already know. These are like the basic one, it's like the timetable. This is like 2 times. Know this, okay? So later on we are going to use this to graph other functions by using this, okay? Okay, number 2. I'm just going to do number 7 first, because this is the same thing, similar. Number 7. Number 7 is what? F of x is equal to absolute value of x, right? So how will you do absolute value of x? We first need to do the table x, absolute value of x, right? Which is f of x is equal to absolute value of x, right? So what do we get? Here also pick some number, negative 3, negative 2, negative 1, 0, 1, 2, 3. So you know exactly what to pick, you don't have to think. What is absolute value of negative 3? 3. Absolute value of negative 2?
1, 0.
So you know your ordered pairs here, right? So now what do you do here? Pick these values, locate these values on the coordinate plane, 1, 1, 2, 2, 3, 3, negative 1, 1 here, positive 1, 1, 2, 2, 3, 3, positive 3, 3. So the absolute value graph goes like this, guys. This is always the absolute value function. You see this? Very easy, right? So what is the domain here?
Same thing. Negative infinity.
Here also we can pick any possible, right? So we are done with the domain for these two. What else we need to do here? Range. So let's find what's the range for both of these. What's the range? Can we get any negative number for this range?
No.
It's always for this function, you see according to the function. Function is a rule. According to that rule, we will never go below 0. Okay? So, what is the range here? 0 to positive infinity. Is 0 included?
Yeah.
Yes, 0 included and infinity. So, if you have open here, that's wrong. It has to make sense exactly one little, you can't say this is a mistake like if you have open here, okay? 0 is part of the range here. Range is all the y value. All the y value we are going to get by using all possible x value is 0 to range. How about this one, guys? 0 to infinity, including, so far good? Okay, so that's number 2. Number 3, I'm going to do f of x is equal to, this is, so we did 3 already, right? So now I'm going to do x to the 3. I'm going to kind of do this real fast, number 4 here, x to the 3. So this one, still we need to do what?
Table.
Table. You need to show the table. Remember guys, I have told in this class, you're not doing the work for you, right? So even though you can do the mental math and come up with the numbers, it says the requirement, show your work, create the table by creating a table of ordered pairs. Okay? So this is your story, you're telling how you got it. So what? X here, f of x is equal to x cubed. This is the y value. So here, negative 3, always you can go with this. 1, 2, 3. So what do I here? Negative 3 cube is what? Negative 27. Negative 2 cube is? Negative 1, 0, 1. What do you get here? 8, 27.
54.
Huh?
Juice is the next one.
Are you okay?
Yeah.
Okay, so now. You guys can ask questions anytime. Make sure that. Alright, so now let's 0, 0 here. Negative 1 and negative 1, right? Negative 2 and negative 8. Negative 2 and negative 8. Negative 3 and negative 27 is all the way here somewhere, right? And positive 1 and 1. Positive 2 and 8. Positive 3 and 27 somewhere all the way up there. So now, graph is going like this guy. Yeah. Have you guys seen this type of graph?
Yes.
Now this is not a straight line. You need to draw the graph like this. So all the graphs, you need to show me at least five points. You need to label at least. Now if you do like this, if you do the graph like this, it is wrong. And if you, when you do this work, if you are not doing on the graph paper, if you mark like this, I don't know, some people like do like this and then try to graph, you get really bad figure. It's not. Okay? So you have to be careful here how you divide your sections on the coordinate plane. Okay? And get the right point and label. Now you don't have to label the point here. I should be able to read it by looking at this. Oh, this is. Okay, you don't have to put the point here. Just make sure it's crossed like that. So I know you're telling the reader what exactly that point is. Okay? Okay, so this is, okay, what's the domain here? And range. Negative infinity to positive infinity, very good. What's the range? Negative infinity to positive infinity. Very easy. Okay. The next one we are going to do, f of x is equal to, this is number 5. f of x is equal to square root of x. Let's do the square root of x one. I'm going to erase this class. If you improve, those who did not do really good on this test, last test, if you didn't get a B or A, at least a C, I might do something. I might give you guys like a little extra credit thing, or maybe a retest again for some of you guys, those who need it. But you need to do really good on this test. If you pass this test and show that you're learning and trying to do well, I'll give you a chance to do better on the other test. But if you fail this test also and not doing the right work for this test, even if I give you another retest, it's just going to be extra work for me and it's not going to help you. I'm sorry, I'm just letting you know. So those who are not giving a practice test for this one, right? But you know what to learn, right? And this test actually is going to be easier because, okay, it should be much easier. Okay, so this coming up test, number 2. So what do you have here? Table of ordered pairs, x and f of x is equal to absolute value of square root of x, right? So pick some numbers here. Negative 9. When you pick x equal to negative 9, square root of negative 9 is undefined. We can't get a, we are only looking for real numbers here. We don't have any complex numbers. Okay? We can't locate the complex number. So negative 9 is part of the domain? No, because we can't reach the y value.
We tried to.
We cannot reach negative 9. Square, we know square, I did give this note to you guys before. Square root of any even root of a negative number is not a what?
Not a real number.
Real number. So know this, because this is all you need, not a real number. We can't locate it. It's not a real number. Only real numbers we can locate on the coordinate plane. Okay? Okay, so what? Negative, what value we can pick here?
1.
So we know can we pick 0?
Yeah.
Yes.
Square root of 0 is 0. Can you pick 1?
1.
Yes.
Square root 1 is 1.
4.
To make it easier, what's the next square number we can take?
4.
4, very good. So let's take 4, square root of 4 is 2, right? What's the next value? 9, 3. We can pick other than we have to use a calculator to use the number, right? So 16, what?
4.
4. So like this. So now we are ready to graph this, right? 0, 0, 2, and no, 4 and 2, 9 and 3, right? So the graph is going, starting from here, going like this. It's little increasing here. Okay? 4 and 16 and 4. Okay? So you guys can see this, right? It's a curve, it's not a straight line again, guys. Okay? This is all curves. Straight line is, so you need to do a smooth curve. It's not a curve like going like this. It's not curve with sharp. Okay? It's a smooth curve. So this is what? Square root of x function. Square root function. What's the domain?
0 to infinity.
0 to infinity. Very good. Including 0?
Yes.
What's the range?
0 to
Infinity, right?